The broadcast is now starting. All attendees are in listen-only mode.
Okay, everybody. Krishna Vedala here from IUCEE. I really appreciate all of you joining us. I know it's Diwali Eve tomorrow, day after Diwali. So happy Diwali to all of you as it's coming up this weekend. And we have with us an expert friend of ours from the Silicon Valley chapter, as some of you might already know. We have a lot of friends in Silicon Valley, so they formed a Silicon Valley chapter of IUCEE, and they'll be having occasional, regular webinars from experts on the west coast of the United States. Of course, because of the time difference between the west coast and the east coast, these webinars will be a little bit later than the other ones, because normally we have these webinars say at 3:30 or 4:30 in the evening, in the afternoon, for faculty and students in India. But we don't want to wake up our friends in the West Coast. It's too early. So even 7 a.m. is, I think, a little bit of an imposition, but I'm glad there are some people willing to do it. So thank you for your patience. And today we have with us Adrish Sannyasi, who is, I think I put up the screen here for him. That's him. And he's going to talk about enabling hands-on real-world training for all students. And the abstract many of you have seen. He's a senior, Adhish Sannyasi is a senior level solutions architect and customer success leader with Google Cloud, with a background in software engineering and clinical informatics / data science. He focuses on solving problems in the healthcare delivery and helping provider and payer organizations on improving customer experiences through data warehousing, healthcare analytics, secure cloud infrastructure, and APIs. Adish obtained a BS Electrical Engineering and graduate certificates in biomedical informatics and medical data modeling analysis from Stanford School of Medicine, MBA Operations Management from University of Maryland. Quite an impressive background, multidisciplinary background. And prior to joining Google in 2018, he was a machine intelligence startup. He worked at a machine intelligence startup, IUCEE, as a healthcare data consultant, and before that he had sales engineer, healthcare analytics special roles at Splunk and Oracle Corporation, and as a healthcare IT technical consultant at Deloitte. Wow, okay, so fantastic. Thank you all. Thank you, Adrish. And I will make you a presenter, and we'll be off, way to go. So I made you a presenter, Adrish, and at any time you can go ahead and click show my screen, and those of you who are participating anytime, just text your questions or comments as we move along so that we can accumulate them and have a discussion towards the end of the session. Okay, great. Yeah, because your screen.
Thank you, Krishna.
Yeah.
And let me make sure that I can actually send it.
We can see your screen. We just have to put on the slideshow mode. Yeah.
Yeah. Can you see my screen?
Yep. Perfect. Full screen. Yeah.
Oh, good. Okay. So thank you everybody for joining today. So we'll talk about how we can build stuff in cloud, and I generally in my work I talk to our customer how they can use cloud to transform their business, helping their customers. I think this is a great opportunity also for students and teacher in reimagining how student could learn and get the experience they need in order to get a job in the life, and also just to get the knowledge of a variety of things. So that's what I'm very excited to talk to you guys, how we can take advantage of this capabilities that we all have access to now. I think we already talked about my current role is solution architect in healthcare, and I have background in a variety of things, data warehousing, cybersecurity, and stuff. First, I'll start talk about why cloud computing, why this is now becoming such an important part of Fortune 500 companies, why people are coming to it. And then I'll start talking about how students and teachers could take advantage of this and how we can create projects for your students using cloud and some of the open data sets that is available in the cloud. So why cloud? I think there are such a lot of benefits to cloud that these are some of the examples of that. Of course, one thing is cost, that you can now run a business without running a data center, which is a very expensive capital investment that any entrepreneur or any CEO has to do in order to run the business. The second is collaboration. You can now collaborate with your remote participants. Let's say you have a developer in other countries, or it is much more easier to collaborate using cloud tools. Some of you already use Google Gmail or other kinds of mail system. That's an example of cloud. You can use Google Doc. You can share Google Doc with others. And that's the early example of how the cloud applications got created. So that is accessible by anyone in the globe. And then that collaboration is, of course, comes with access. If you have access, then you can collaborate and innovate together. And then other capability that cloud provides is now you don't need a very expensive server to start your business. You can be starting small and develop your application, but then when you need, you can scale it up. And of course, it is eco-friendly because a lot of data centers that Google and other providers are working on, they are much more efficient in using energies, and also consolidation of data center increases the footprint of these eco-friendly type of data centers. Security, cloud companies have significant resources dedicated to making their data center application network secure. It is hard for all the companies to have those type of security infrastructure in place. So in general, cloud is much more secure than any other third-party data center because of the way it is designed from making security as a first-class citizen for designing the cloud data centers. And the last thing is reliability, because cloud is not just one data center. You have data center across the world, across the various parts of the country. It is easy to fail over if one data center server doesn't work, and even within the same data center, there is lots of failover mechanism. So I think the first thing for cloud is a network and infrastructure. This is infrastructure is built. It's a high capital investment. However, this gives us a tremendous opportunity for the customer and obviously for the students. And the origin of cloud is possible because now we have better bandwidth. Previously, it is hard to do. Now you can imagine in India, even compared to 5-10 years ago, your bandwidth that you have in your residence or your institutions is probably went up pretty significantly in the last couple of years. So that's one of the reasons now we're able to access the cloud computing resources much more effectively than before. That's an example of how the network are distributed across the United States and across the world. Even there's a new data center came out in Mumbai, but there's a variety of data center across the world that you can take advantage of. As I mentioning about the collaboration, in previously before cloud, you have variety of legacy system, and even you are same version of Microsoft, even you are in a doing Microsoft Office, for example, everybody could have different versions of the same software. So when you upgrade it, then it's sometimes difficult to share the document. Sometimes document doesn't open. It happens a lot with the Oracle database and other systems. Even they're the same software, same vendor, even changing the version they become very hard to collaborate. In the cloud, there is the same version of the software. Whatever version of database person A he's accessing is exactly the same version the person B is accessing. There's no confusion on which version of the software I'm accessing. And also, that makes the collaboration easier. There's no, I'm actually accessing exactly same software that you are accessing in terms of the Google Doc. There's no difference. And most of you actually probably use a lot of these Google tools, and these are all examples like of cloud computing, how cloud applications are helping all people all over the world. And just to give you an idea, there are 7 products in Google that has more than 1 billion users. We see Google Search, Android, Maps, Gmail, Google Play, YouTube, Chrome, all are having more than 1 billion users. These are all native cloud applications. So Google runs all of these applications in the cloud, as well as making the cloud infrastructure available for others to develop applications, develop any kind of data analysis type of jobs. Another example of how the cloud is becoming native to any device and software. This is a Stadia, which is a new gaming platform from Google. It cloud native device. So all the things in this device stored directly in the cloud. There is no storage that you need in your home. So that's an example of how the future applications or the future devices might be developed. And of course, sometimes you need a local backup, and that is also possible in this cloud infrastructure. You can have a local edge computer that is talking to cloud and take advantage of the data lifecycle management. You don't have to store a lot of data in your edge device, but you need edge device for running some software very quickly. That is also possible in using this kind of cloud infrastructure. After network and infrastructure, the second thing that I mentioned previously is the security and reliability of cloud. Of course, we call it defense in depth. That means there's a security each and every layer of the stack, like hardware, storage, operating system, network, applications. So even if one layer fails, it's hard to fail all the layers. And then cloud is not just for infrastructure, storage, and compute. You can take advantage of all the databases that you generally use, like relational database, like PostgreSQL, MySQL, or NoSQL databases. And in fact, Spanner is a highly transactional consistency relational database from Google. So a variety of databases are available for you to take advantage of while you are developing application. Then for the data warehousing and analytics, there is a significant investment done in creating a comprehensive platform like ingestion, pipeline, with data warehousing, analytical tool, and they work together. You don't have to worry about building this thing from the scratch. You just take advantage, you focus on developing code. And then lastly, AI and machine learning. It's hard to do deep learning in your local computer. You can develop your code, but it is very hard to run the code in a consistently basis and in a high performance way in a local computer. That's why you can develop code, but then run your code in the cloud by using this machine learning infrastructure that cloud providers have. And you have a variety of different things from AutoML, pre-trained APIs, and stuff like that. You can go to your website and learn more about this. But the idea is that there's a variety of tools for people at different skill levels. So all powered by open source TensorFlow. And that's one of the things about the cloud, especially about the Google, is that there are a lot of open source. And the thing that is on open source, let's say TensorFlow is open source and you develop some software in TensorFlow and you want to run in the cloud, that is absolutely possible because you use the exact same software that is open sourced. So it's a highly compatible, interoperable with the open source versions of the software that is already people are using. So in summary, cloud is secure, reliable infrastructure. It can help you unlock the value from the data using machine learning and AI tools. It enables collaborations, and it empower developers to build stuff rather than worrying about the infrastructure. So that's in general what the cloud is. And you can actually go to, and you can use your Gmail account and go to console.cloud.google.com, and you can start using the cloud right away. And everybody gets $300 credit when you sign up, and for in the cloud, everybody gets $300 credit. So to get started, there is no friction. You can go and say, this is my personal email, so it will not do too much here, but first thing you do is enable billing, and then once you do that, then you just go and start building stuff. Like for example, if you want to create a VM, just come here and do VM. It's right now billing is not enabled for this, but that's an idea. It's a pretty easy to get started, low friction way. I highly encourage everybody to try it and see, how you can take advantage of some of the things that's already there without spending any time. So now let's move to the next phase of the presentation, which is how we can take advantage of this cloud for your students, and if you had a teacher, how you can take advantage of this to create projects and learn things in the cloud. So in terms of the skills that organizations are looking for, this is some example of the skills you see here, like AI, machine learning, cybersecurity, robotics, big data, IoT. These are the skills that all organizations need in order to move from the current state to the digital state that they want to go. And cloud is provided two things. One is, of course, you can get the knowledge of the latest stuff that industry is using. You have access to exact same software, exact same hardware that, let's say, General Electric will use or Reliance will use. So there is no difference in the version in a lot of cases. So if you develop capability that is directly applicable to the job that that person will be doing when they're recruited in a company. So it's easy to get started in a career if you have the cloud skills, because it is the same skills that people are looking for, and in many cases you'll be using the exact same software that organizations are using internally to develop or run their business. That's a huge advantage we did not have when I graduated. We did not have the skill. Of course, when you guys graduated as well, we did not have this option. We always worked on lower version or some very clunky version of the software than what organization used to use. So today the access is a huge change, and we really want our student to take advantage of this like a groundbreaking opportunity. So there are a couple of things you could do. You can enable your students to get practice for the stuff you're teaching. Let's say you're teaching some programming class or teaching a class in machine learning or API management, whatever it is. They can get more time for the learning. There is no limit of any computer center, soft computer center that you might have in your organization or in institution, or nobody has to wait to run a software. They can run whenever they are ready, and that gives more hands-on learning experience very easily to the students. And for the student side, they can build what's next, what maybe the companies are looking for, not just build something, but build something that organization would love to use, or maybe looking that kind of skills to develop. You can build your website or apps without any infrastructure, but then you can share those apps with the recruiter or with the company that you have built something. So this is there's no way you can say like, I learned things, but I may not know these things. There is no confusion, because this is you have built it. Your teacher validated that you have built it. So it's a much more refined or much more real example of someone's ability than somebody just read a book. So in terms of the obviously the advantage now is you can be much more creative, you can deliver better results, and then like you can take the advantage of the tools like machine learning in your classroom much more easily, and access other powerful open source software as a part of your course. Now we can say that there are a lot of things to learn, but what I encourage, in my experience, there are only 3 things that are really important that could change many things in your life and also student lives. 3 things are really you need to learn how to be a virtual machine in the cloud, running applications in the virtual machine, or kind of app engine or containers that we talk about. And the second skill is data. Get the data, store data, stream data, and then analyze data using a variety of tools. And then third is artificial intelligence. If you learn these 3 things, then that's a huge in terms of taking advantage of the cloud and then using the cloud tools to really change people's life. The only 3 things you need to learn: compute, data, and artificial intelligence. There are a variety of other things like cybersecurity and stuff, but if you think about cybersecurity, that it's a part of embedded into each and every one of these things. You cannot have a compute without making that compute secure. You cannot store data without making that data storage secure. Or you cannot develop an applications or any ML AI systems without making that system secure. So cybersecurity is all part of this. So as you are doing this learning, compute learning databases and AI and machine learning tools, you'll be automatically learning the cybersecurity and other things that you need to learn, like API management, how to build APIs. All of these things are part of these three things in general. And there are a number of self-paced labs and GitHub examples, and these are all free to anyone, and you can go and start learning. I'll tell you some of the specific things that I found myself useful when I started. So one of the course is in the developer.google.com is a machine learning crash course. And this is a very quick course in introduction to machine learning. However, this provides a significant uplift in someone's skills. When I first started machine learning, a couple of years ago, I actually went to this website first to learn things and do things first, because it doesn't have a lot of statistical theories and all the math that you have to, other courses will force you to learn. This is just using APIs to actually build stuff. So once you build stuff, you'll get excited. You get some excitement, I've done something. And then you can go and learn the statistics and mathematical part of machine learning. But in order to get started, this is one of the best way to get started, actually do something and get excited, get some fulfillment, and then go and learn the bigger things. That's one of the things that developer portal will help you do. And then there's a variety of other things. It's called codelabs.developers.google.com, where you have a lot of code labs. It will go and will go step by step and how to run things like set up your hardware, set up software, build, prepare binaries. So it goes step by step, and it has exactly all the code, all the instructions written. So you can pretty much just copy these things and get started very quickly. And then you can change stuff, and you can do a variety of things. But in order to get started, it provides a lot of starter code. And then there's a GitHub for Google Cloud Platform that has a lot of example of various things in cloud that someone might do, like how to run a machine learning in the cloud, how to do BigQuery, how to do queries in a data warehouse. So there's a huge community here that you can take advantage of all the packages that's already in place. There's a tutorial, variety of tutorials that will help you learn very quickly. And then the next stage is if you go and take the formal training. Some of this training is also available at low cost through Coursera, and then Quick Labs is a resource that helps you actually run these things in a real cloud environment. So it's not just it's not just some code snippets, but it actually logs into Google Cloud, real cloud, and then helps you run things. And you can, advantage is you're not using your credit. It is using credit that Quick Labs already have. And there are ways to access and how to get credits in Quick Labs. But the formal thing is you can get this training at a very low cost. And then what we have is, let's say now you want to create your own Quick Lab or own code lab, that we actually open sourced the code labs that have instructions on how to author a code lab. So for example, you are doing a class for your students, and you want to author a new code lab or variety, get some variations in the code lab for groups of students, you can do it yourself. So you can use the code lab that is already there. If you want to make changes and create your code lab for your students, that is absolutely possible. And you have the access to the exact same tool that someone at Google will use to create these code labs. And then there are training and teaching credits available, where you can, if you're a teacher, you can get credits for learning yourself and for your students. And then let me show you one of these options. So I think here you can go and give your information. You have to give email address of your institutional email address, and you get approved, and then what courses and stuff like that. So you have to give some information about this, but most of the time you get approved for at least for some credits. So please take advantage of that if you are creating something for your students. And then there are lots of training and educational credits available. And these are I investigated while I was preparing for this presentation that are significant. Like we talked about Coursera and QuickLab. And if you use your school or the college issued email address, there's a significant amount of credit you can get, like 200 QuickLab credits. That's a lot in terms of accessing so many different QuickLabs. And then faculty member gets 5,000 QuickLab credits. And there's 13 courses in Coursera that you can access, fundamentals of Google Cloud, machine learning, preparing data in BigQuery, and then a variety of things like application developments in Kubernetes engine and stuff like that. So it's very significant in terms of how you can take advantage of some of the free stuff that is available to you. So now, lastly, what I want to talk about is how you create student projects using open data and the cloud. I think this is what I think where I'm looking for some feedback from you. I can give feedback to Krishna, like how if you could create these projects, custom projects for maybe for the final semester students or whatever. I don't know what the structure you have, where you can, students can work in a team to really develop a real life solution, and that is possible because of this open data in the cloud. And I want to walk you through how that might be possible, and you may need some help in to get this right. But let's see, how we could possibly imagine creating a project. So I think there's 5 steps in creating a real life experience. One is to understand the problem and understand the user workflow and how do I improve that certain workflow. If we're working on improving a cancer detection system, they need to understand why that problem is important to solve, who is going to use your software, and where it is going to be used. Is it going to be used in a clinic versus in a hospital? That may have impact on how you develop your application. And what is the success criteria? What the customer is looking for? Are they looking to improve their accuracy of the cancer detection system, or they're just improving user experience because their application is really bad? They want to just improve the application. So understand why it is important to do. And then the student can identify the data, collect the data, explore the data that is available. A lot of the data in the imaging space is available, let's say, online. But there are data available from India government as well. I was doing some investigation on that last night. US government, UK government has done a lot of open sourcing of the data already, but I found that India government has done open sourcing of a lot of data as well. So that may be the starting point. But if you want to work on the healthcare data, medical data, that's also available online, de-identified fashion. So many people have contributed to develop those kind of. I have a link for those in this presentation. And then the student can perform analysis, develop and evaluate models if you want to develop a statistical model, and create a set of conclusions from the model, and then deploy the model as an application in the cloud. And that's really what advantage of cloud provides. And previously, even if you do this kind of data analysis, it's very hard to develop an application and then share the application with others. With cloud, you can do that very quickly. And then number 4 is you can ask the student to develop a business case for the product and solution that they're pitching. Let's say it's a cancer detection system. What's the business case for the product? Why somebody's going to buy? Why they've planned and how to do this development in a real life situation. Even they don't do it in a real life situation, they can write a plan because they already done the prototype in the cloud. And then build a post-deployment monitoring plan, how someone is going to monitor the performance of the cancer detection system. So that's really how the a software engineer or a product manager will work in an organization. It's actually simulating the same experience for your student using the cloud as a tool. And then because some of the things are already available to you. Lastly, a student can present the analysis and their conclusions in a blog post or in a GitHub repository and share with others. I think creating this kind of projects is going to help, first of all, student to get through the real experience of how to really develop a product or solution from the scratch, and then take advantage of the cloud tools to develop this quickly in a part of, let's say, 3-month or 6-month project. And then lastly, share this with the recruiter companies or someone, anybody who is looking to recruit this kind of skills, so that they can see, this is the real stuff student has done and is validated by the teacher that, student has really worked on it. This creates a significant confidence in the recruiter mind or the organization's mind in terms of the capability that student might bring to their organization. So that's the proposal I have. If you use this cloud, use all kinds of open data that you have, but then work on creating this real-time experience. And if you need some additional assistance here, you can contact Krishna, and then we can see how we can help out in creating this kind of projects. So in terms of the public data sets, so Google Cloud has a number of public data sets already hosted. So you can go to this link and you can see all the data sets that is actually hosted in the cloud. And these data sets are from variety of domain. It's not just in one domain, like a healthcare, in retail, financial services. Depending on somebody's needs and somebody's desire, you can choose a variety of things like weather, climate, transportation, cryptocurrency, and many others. And this has a list of things. It's almost like close to 123 different databases already available. And there are other databases beyond this that you could use and upload it to cloud. And I'm going to show you other sources of data as well. So these are some of the sources I compiled, which can be some of the sources are actually directly applicable to develop the machine learning model, develop the AI models. For example, Kaggle.com is a website that organizes a lot of data science competitions, and they have a huge array of data sets available as a result of that. And then there's available from IUCEE, University of California, and and then data.gov.in, that's I found yesterday, and then CMU. There's an ImageNet available for imaging, and then there's a sentiment analysis data sets, Amazon review data sets available from someone here. So there's a variety of data set depending on the problem that you are giving. You can ask students to one of the first tasks might be to collect the data, or if the data doesn't exist, maybe they can contact the organization and see whether that organization can give some data as a part of the work. But if you follow this kind of approach, then it helps generate the need for collection of the data, and that itself is a lot of significant work that happens in an organization. When you develop models in Google or any other organization, we don't just start developing the model. We spend significant amount of time collecting the data, curating the data, and labeling the data. So that experience that a student will have in actually going through this collection process, labeling process, and if the data doesn't exist, what's the gap, how to find the data, whom to call to get the data, is a significant skill that we are looking for. And it needs a lot of curiosity, gap analysis, understanding the problem. So even if you haven't developed anything, you just define the problem, define the workflow, and start collecting the data. That itself is a significant project, and people can learn a lot of things by just going through these two steps. And once you know the data, then you can develop model, do your analysis, go to GitHub or present through cloud. That's a good thing. But that's like a second step. The first step is to do the collection. So once you have this GitHub thing done, applications are shared, then the thing comes, somebody has to really sell it. The selling skill you can develop, Now you have these applications, now you have all the data stuff. How do you really position your solution to customer? Why somebody will buy your product? What's your proposal? I think these are the like whole life cycle of activity you can simulate, I think, using cloud and data sets. I think that's pretty much is my presentation.
Okay. Let's have some discussion. Yeah. So thank you, Adrish. This has been really, it's been very fairly high level for me because I'm not in the cloud computing area, but I'm sure many of the participants, there are more than 30 people who are attending, and would like them to jump in. And I'm particularly interested in the offer that you made to be able to help anybody who wants to develop student projects using cloud computing the way you suggested. And and so that is a great opportunity, and I would like to ask the audience to now jump in. We have a few minutes for discussion. We have representatives from many colleges, and I'm sure many of them have backgrounds in many faculty have backgrounds, and some of the administrators are there online today. So let us at least start some small project where we can each of your colleges where you can collaborate with the Adrish and get some help in getting some student projects moving. So let's get some interaction, folks. Let's send some comments, suggestions, etc. In particular, I like to pick on Rio here, who has joined us as a principal of a St. Joseph College. What do you think? You have a team of people here on our webinar, and what do you think? Is there something here that we can connect with Adrish on and maybe follow up in a very small way to begin the process of helping, and maybe some of you already are doing many projects on cloud computing within the cloud, and if so, then let us hear from you what your experiences have been in doing some of these projects. Those who are not doing already, let us find some way to take advantage of this unique opportunity to partner with Adrish and move forward. So let's do that. And maybe Anil Pandit, I know you joined a little late, but I think you might have some ideas on how IUCEE can take this forward with various colleges. I think this is an excellent opportunity. I'm going to unmute a few people. Let's see. I'm going to ask Rio maybe to think about it. Rio, would you like to comment on the situation at St. Joseph's, and if there's something there? Opportunities with St. Joseph? Think about it. Okay. Let's see. Are you able to come in, Rio, or do you have any thoughts? Or you don't want
to? Nothing much right now.
Okay. So let's let everybody think about it, and let's see. Get some comments. I know I've got a question here. Anil, do you want to make any comments, suggestions here? I know you said hi.
Can you hear me?
Yeah, we can hear you. Go ahead, Anil. Yeah.
Okay. Okay. This is fantastic. Because it's an upcoming science, it's an upcoming stuff which so many students really approach. How can I do a project? Any project which they are doing, if they can fill in that data, put it in the public domain, use the data in the public domain, I think that will be wonderful. It's a great source also for internship, as I see it. Let's see and discuss how we can take it forward, and it will be indeed very nice to interact with Adrish.
Okay. So what we need to do is set up a group of our one. I mean, we have several colleges, I'm sure, that be interested in this. We need to connect with their cloud computing administrators and principals and see if there is some way.
Yeah, it can be a subset of project-based learning.
Right, and this is good. Prashant Revankar is asking, how can non-computer students use cloud facility in allied community?
Yeah, I can answer that.
Yeah,
I think that's really what one of the goal of cloud is. Because a lot of the infrastructure stuff is taken care of. You don't need to worry about setting up server, installing application, installing databases. I think this is a unique opportunity for non-computer science like chemical engineering, mechanical, or any other engineering, or non-engineering as well, to do something very quickly using the managed services in the cloud, because a lot of the things in the Google Cloud and possibly another cloud as well is a managed service where you can use things as a service. Like you don't install databases, you just write SQL or load your data. That's much more easier to do. So if you can take advantage of some of the code lab or some of the training that is online training available, you should be able to become productive very quickly. In at least in the area that I work on, data analytics, I have a lot of people who are from clinical background, like from medicine, nursing. They never went to computer science class and they never had IT classes, but they learn SQL, and then using SQL, they are doing very interesting stuff now.
Okay, can you, Adrish, I mean, since you're familiar with this particular field of healthcare and so on, can you, I mean, for people like me, for example, who are not really computer scientists, I'm a materials guy, Can you give me just a simple, very basic, simple example of perhaps a student project and how you would do it in your particular field, how a student would work on a project? Can you, I know
Yeah.
you're not prepared for it, but if whatever you can do.
No, I can give example because I
Some
do it
example,
every
yeah.
day.
Great.
So for example, um, there's a lot of data sets available for image detection and image detection. Let's say in a finding cancer in a nodule in a pancreas or something. So that data sets is already labeled. And label means I already know which one is cancer data, which one is not a cancer cases. So if I have this data sets already ready, only thing I need to do is to get this data and then run through the ML, I'll call it auto ML. So auto ML is if you don't have any data science background and if you want to take advantage of the machine learning, you can use a concept called auto ML where it will run the model for you. You don't have to be a data scientist, but it's going to run the model and then give you the output. And then you will understand how this data set is used to create the model, and then you can use that output, and then there's another set of capability you have to make that output available as an API without writing code. So these are the capabilities like AutoML, curated data sets, and then running a running a function or developing a function without writing code. I think these are the three capabilities I can see would be helpful for any non-engineers or non-computer scientists coming into the field and really do their job without writing too much code or maybe writing a couple of lines of code.
I'm sure some people in the audience today are actually computer scientists, faculty who have been teaching cloud computing. And if you are, could you just jump in and give us some idea of what you do and in your cloud computing course, if you're teaching it, and how you think what we've heard today might be of value to you and your students? I'd like to hear something from you guys also. Obviously, some of you want your lecture slides. That's easy to do. We'll be having a recording of this webinar, and I'm assuming, Adish, you have no problem with trying to.
Yeah, I can send you the slides so that we can distribute.
Okay, so Pawan Kumar is saying, okay, is from Anant Lakshmi College, and I'm from electrical background. I want to know how cloud computing can help me. Okay, well, that's a very basic question. So that's I think many colleges are teaching cloud computing. So I am hoping that we can connect with the people who are teaching cloud computing and see if they can connect them and make them much more. They may be teaching more of the theory subject without any practical application. Here's an opportunity to have the cloud computing faculty start connecting with the source of cloud computing, which is Google Cloud, and actually do some projects. That's fantastic. So let's see what else. Any other comments, suggestions, and I think Anil, I think we need to bring this up with our larger group, who may not have been able to attend today, who might be interested in building this up. Okay, so some kind of a capstone projects and how to help as the final year students develop capstone projects with the help of their faculty. So that's so. Which are this from your understand awareness of which universities, maybe in the United States or other places, are really doing a good job of taking this cloud computing and student projects seriously and developing them in a significant way. What any thoughts on that?
Yeah, I think you can look at. I think Coursera has a lot of example of that as well. But if you look at the Stanford University machine learning course, that I think they uses all cloud, Amazon and Google Cloud, and they take all that credits that available, and maybe they have special stuff with the Google going on as well. But Stanford University machine learning course is a great example of that. And then anybody who is doing that deep learning course, is definitely using cloud, because you can't really run deep learning in laptop or any other computer effectively.
Right.
So all the deep learning courses, they are using some kind of cloud.
Yeah, we've had several people in deep learning, I think in India, who have been offering deep learning courses to our faculty, and I'm wondering maybe someone may not be here today. Is anybody in this group has involved with a deep learning course that comes out of, I think, Deepak from the, I think the Deepak Kirk from Bennett University has been going around our colleges offering deep learning courses. Maybe they can comment on it. And okay, so yeah, okay, great. So I guess this is a great beginning. I think an awareness for the many of our community to know that this is something that's exciting and on the horizon, and I think we need to absolutely be able to be part of this movement of change that is happening around the world. Otherwise, we'll be left out in the darkness and dark ages. So I think our colleges should learn to take advantage of this and get to the point of taking these types of technologies to actually do real projects. So that's great. So I would like to thank you now at this point, and I really appreciate your taking the time early in the morning. I know you have a long day ahead of you. So Adrish, thank you so much. And let me see. Let me just do a final check on any additional comments or questions that might be up there. Okay, so I guess that's pretty much it. Okay, thank you so much. Okay, take care and happy Diwali if you're doing Diwali.
Yeah, happy Diwali.
Yeah.
Thank you.
Everybody, happy Diwali, everybody. Thank you.
Yeah. Happy Diwali.